Oh, hello, geometry friends. Day 3 of proofs. This is lesson number, let's see, 13. All right, lesson number 13, day 3 of proofs. I'm only going to do 2 of these with you, and then you can go off and use the answer key and to help yourself with the others. Some of these are a little bit more difficult than others. Maybe I'll do more than 2, but we'll see how much time this takes up. One thing that I want to prove because we've been talking about how congruent chords intercept congruent arcs. We've used it in some proofs. We've used it in some calculations. Now let's prove why it's true. So we're going to prove that congruent chords intercept congruent arcs. And we're going to do that by using the third piece of that phrase that sometimes occurs, and that is congruent chords intercept congruent arcs and congruent central angles. So let's first draw in some auxiliary radii, shall we? Let's create triangle COH and create triangle ROD. So draw in those auxiliary segments. Now, because the segments that we just drew in are radii of the same circle, then we all know that they are equal to each other. All radii of the same circle are equal. We're trying to prove eventually that arc CH is congruent to arc RD. So right now we have segment OH, OC, OR, and OD are all equal because they're all radii of the same circle. So maybe I should go ahead and mark those in my diagram. That is equal to that is equal to that is equal to that. Okay, so what else do we know? Well, if we were given in the first place that CH is congruent to RD, maybe we should mark those equal as well. That means we have 2 congruent triangles by side, side, side. Now, how does that help us? Well, once we have the 2 congruent triangles by side, 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 we can match up the angle COH and ROD because corresponding parts of congruent triangles are congruent, or CPCTC. That gives us a pair of congruent central angles. Oh, but we know congruent central angles intercept congruent arcs. So if we know congruent central angles intercept congruent arcs, and we know that arc CH equals arc RD, technically I think I should have a measure of arc CH equals the measure of arc RD, because congruent central angles intercept congruent arcs. In 5 steps, guys, we're done with our first proof. So this just goes along to literally prove that congruent chords intercept congruent arcs because they would also make congruent central angles. We created the central angles in order to get to our proof, but it worked. When all is said and done, our congruent chords that we had to start with created congruent arcs. And in between, we had the congruent central angles. So they all go hand in hand. All right, next. One of the rules that we haven't used it a ton. Parallel chords have congruent arcs in between them. So we are going to take parallel chord PA and RL. Chord PA is parallel to RL. That's our given in circle O. And we are going to prove that arc PR and arc AL are congruent. Now, in order to do this, we are going to need an auxiliary segment. Just to keep us all consistent, let's draw in auxiliary segment PL. Now, drawing in that auxiliary segment created a couple inscribed angles from our parallel chords. So that means that angle APL and RLP are congruent because if lines are parallel, then alternate interior angles are congruent. Next is zigzag. That's one of the things we were looking out for when we were doing proofs back in November, December. Actually, even started that in October with the parallel lines cut by a transversal. If the lines are parallel, alternate interior angles are congruent. That means that arc PR is congruent to arc AL because these are inscribed angles that are congruent. So congruent inscribed angles intercept congruent arcs. That's kind of backwards from what we've done earlier. We took the congruent arcs and made the congruent inscribed angles, but it goes both ways. Now we have the congruent inscribed angles, which makes the congruent intercepted arcs. Done. All right, that one was a little too short. I should do another one with you just to help. If you don't feel like you need it, you can always put me on pause and then go ahead and do the proof yourself. But I'm just making sure everybody gets done writing. Looks like you're all set. If not, you can just pause it and finish and come back. All right, look, it says it's time for the little birdies to fly from the nest. In other words, do these yourself, but I'll help you out a little bit. COD is a diameter. It's part of our givens. B is the midpoint of arc CD. B is the midpoint of arc CD, with CD being a diameter. All right. Well, if just thinking out loud here, if B is a midpoint, that means I know that arc BC will be equal to arc BD. So that'll come into handy. Let's first figure out what triangles we need to get similar. We've done this enough to know that we're trying to prove the product of some segments. The only way that can happen is through angle-angle similarity. That means I have the Disney happy ending, where I'm going to use CSSTP, the cross product property. I know where my proof's going to end. I know that this cross product has to come from a proportion, so I can go backwards and set up the proportion. And I know that the only way to set up a proportion is to have two similar triangles. All right, so I know all that, and I know what pieces I need to have multiplied together. The issue is what triangles. I mean, there's a lot of triangles in this diagram, so which triangles are we going to focus on? So here's what we do, just like we used to back in the old days. We look at segment AB. That has to be the side of one of my two triangles that we're going to prove similar. And then ED has to come from a different triangle. Okay, but those two pieces, each from a different triangle, will be used. And then let's see, AD. Now, could AD be used with the red segment to make a full triangle? Or could it be used with the blue segment to make a full triangle? Well, I think red, because AD would then create triangle AED. And that would give me one of my two triangles. Let's see. The other segment here is CB. That's pretty big. That can be used with the other blue side for angle ABC. All right, so now we have our focus. I know what triangles we want to prove congruent. And now it's a matter of doing that through our steps of stuff we know. All right, so let's see. What do we want to do first here? We know where we're going. Oops. Angle ADC is equal to angle ABC because both of those angles intercept the same arc. ADC is an inscribed angle that intercepts arc AC. And then ABC is an inscribed angle that intercepts the same arc. So inscribed angles that intercept the same arc are congruent. Now the next couple of steps is where we use B being the midpoint of arc CD. So you're going to get arc CB congruent to arc DB because the midpoint creates two equal parts. Then you can have inscribed angles that intercept equal arcs, or inscribed angles that intercept congruent arcs are congruent. Okay, so you can check the answer key for that if you need to know the exact steps, but I pretty much just told you and laid it out for you. And the rest of them, you're on your own. Use the answer key as much as you need. That's why it's there. Good luck. I'll see you soon, and goodbye.